Hi everyone, my name is James Dominic. Today I present the work Program Comprehension in Virtual Reality. This is done by myself and Brock Tubre. We are both PhD students at Clemson University. Working from home has become popular in the recent years. However, events like the current pandemic has made it a requirement and not just optional for programmers to work from home. So here I would like to discuss some related work. Virtual reality as a tool has been used in a wide variety of research studies and research field including medicine, gaming, training, education, therapy and more. Training doctors and planning surgeries and distracting patients with anxiety has been a mainstay of virtual reality research in the recent years. Virtual reality has been used to provide architects and clients with design visualization of buildings. Training and education programs for children in controlled safe environments is also a research area which has advanced significantly in virtual reality with the use of virtual reality. There is limited research of virtual reality in software engineering. There have been research which shows code as depicted which depicts code as cities or like different municipal units in virtual reality so that they could visualize the code better in virtual reality. However, there is no research which deals with comprehension act of software engineering using virtual reality. So we propose a study where programmers comprehend code in virtual reality. The code which so the programmers were required to comprehend Java programs, and these Java programs were basic entry-level programming constructs like finding maximum and minimum values in an array of values, or computing the median of a list of values, or like determining if a string is a palindrome or not. There were a total of 8 Java programs the programmers could comprehend in a time of 40 minutes. So once the programmers comprehended the Java programs, they were required to summarize the code or provide us with an output. So they had an option to just give us the median value, or they could summarize it saying that this program computes the median value if they are feeling more comfortable that way. We also requested the participants to fill out the NASA TLX survey once they completed the completed the experiment. We have two different settings where the participants participated in the study. We had one setting where they used virtual reality to comprehend source code. For this, we developed a novel virtual reality platform which we call VirtualDesk. We used Oculus sorry, we used HTC Vive headsets and HTC Vive trackers so that we could provide so that we could provide a virtual reality environment at the same time provide keyboard and mouse tracking so that the programmers could use the keyboard and mouse inside the virtual reality environment. So the keyboard and mouse was tracked using virtual HTC Vive trackers, and there was a virtual keyboard and mouse available in the virtual reality environment, which is one-to-one tracked to the physical keyboard and mouse, and also provided feedback in the form of visual feedback. For example, if someone presses the J key, if someone presses the J key in the virtual keyboard would light up and also go down and come back up like a natural keyboard would do. Similar to that, the mouse also had a visual feedback feature where whichever button of the mouse was clicked, the button would light up and then dim back down. So we call this system VirtualDesk, and this system was used by programmers to comprehend source code. Programmers also, a different set of programmers also comprehended source code in a traditional desktop setup where they were comprehending source code on a traditional desktop. We had a total of 13 graduate student programmers in each setting, bringing our grand total to 26 graduate student programmers who participated in the experiments. Both settings, programmers performed the task in virtual reality setting. They performed it in the virtual reality environment, and in desktop setting, they performed that program comprehension task on a traditional desktop. They summarized 8 Java projects in which were presented in a random order, and in both settings, they received a NASA TLX survey after completion of the experiment. So we pursued two different research questions during this experiment. The first research question was, do programmers need to concentrate more when using virtual reality to comprehend source code? Does this concentration, or like the increase or decrease of required concentration, affect their program comprehension performance? The second question which we looked at was, does perceived productivity differ in virtual reality setting versus desktop setting? Do the programmers feel more productive in either of the settings? Here we present the results of the measured comprehension. We found that participants in desktop setting comprehended 93 code snippets and comprehended 70 of them correctly. That is about 75% of the total code comprehension was successfully or correctly comprehended in desktop setting. Whereas in virtual reality setting, programmers comprehended a total of 84 code snippets and comprehended 55 of them correctly. This brings them to only a 65% success rate. Here we present results of the NASA TLX survey. We find significantly more overall task load on programmers in virtual reality. To analyze the significance, we used a Mann-Whitney U-test. We also find that virtual reality programming is more physically and mentally demanding compared to desktop code comprehension. Here we present the results of perceived comprehension. We do not find any statistical difference between the self-reported productivity scores between virtual reality setting and a desktop setting. So coming back to our research questions we were pursuing, we find that there was an increased task load, mental demand, and physical demand put on programmers in virtual reality setting. And we also find that added requirements or added task load has resulted in a decrease in program comprehension performance. To answer the second question, that is, does programmers perceived productivity differ? We did not find any difference in perceived productivity between virtual reality setting or desktop setting. So programmers thought they were equally as productive in virtual reality compared to desktop setting. So we would like to expand on this work and provide a program comprehension model for remote developers. We also would like to introduce full body avatars into the system so that we could increase presence in the virtual reality environment. Right now, our virtual reality system works only with the HTC Vive system. It could also work with the Oculus system, but they are all tethered systems which which we the current system is only compatible with tethered systems. We are working on a system or modifying the existing virtual desk system so that we can deploy it into non-tethered virtual reality headsets like Oculus Quest. We are also investigating the use of VirtualDesk for onboarding of software programmers. Thank you.